Okay, we are recording. I have myself and Eric, and I'm glad that Eric showed up, or we couldn't have a video. Okay, well, here's the thing. This assignment and this quiz is going to be mostly review. There's no this chapter that you're reading for the book. There really isn't any free response questions or videos that match up to it. I'm going to jump over here. So the chapter you're reading in the book, you should read it, but really most of the videos are going to come in this next chapter 10. Okay. So chapter 13 is going to be, is not going to be as important in terms of preparing for the AAP exam, but still, please read it. And I don't think there's any videos, and I should have put that in there, right? Let me go back here and check. I don't think that there is any videos for assignment 9 because I couldn't. No, there's not. Okay, so, but everything we're going over is going to most assuredly be on the AAP test and the final. So this is an important. These are important concepts in this assignment for you guys to master. Okay. So we are looking at corn, and corn is an input, is a factor input in the production of ethanol, which is an alternative fuel. And we're going to assume that corn is produced in a perfectly competitive market. So the first thing we want to do is draw correctly labeled side-by-side graphs for the corn market and a representative corn farmer, which would be the firm. So we want the market on the left and the firm on the right. And we want to show the equilibrium price and quantity in the corn market, PM/QM, and we want to show that the farmer is earning zero economic profit, which means that price is going to need to equal average total cost. So what does that graph look like? Well, let's find out. In fact, let me close this out so we don't get confused here. Real quick. Yes, we'll save changes and bring up our problem here. So the graph is going to look like, so here's your market. Okay, now this isn't in here yet. Let's just draw this guy out for a minute. This is going to come a little bit later. So you initially want to draw your graph with your price right here, okay, right there, okay. Now, as we get into the problem, you're going to draw more on the graph, as you can see right here. So this is what your graph is going to initially look like with your demand curve D1 right here, your price PM, and then you want to show right here the firm earning zero economic profit by showing the average total cost curve at the minimum point, because remember, marginal cost always equals average total cost at the minimum average total cost. So you want to show that the minimum point of the curve right there where it crosses or where it intersects the marginal cost curve. And we know in a firm that's in a perfectly competitive market, marginal cost always equals price, and where marginal cost equals price is where they're going to produce. Okay, so that's what you want those two graphs to initially look like. All right, and you can freeze the video if you're watching it and make sure you get those graphs correct. Now, the next thing they're asking us to do here is assume the demand for ethanol increases. So on your graphs in part A, show what will happen to each of the following in the short run. The market price and quantity of corn, labeled Q star and P star, P and Q star, and the area of the profit or loss earned by the representative corn farmer or the firm, shaded completely. So now we add our changes to the graph. So we want to show that since corn is a input for ethanol, if the demand for ethanol is going to increase, then they're going to need more corn to make more ethanol. So the demand for corn is going to shift to the right, is going to increase. And that's going to drive the price up to P star and drive the quantity produced up to Q star. So we're going to have a higher price over here. So now the firm is going to produce once again where marginal cost equals price, so with a higher price and an upward sloping marginal cost curve, it means that they're going to produce more at this higher price, but the average total cost curve doesn't change. So that means that now the price is above, right here, is above average total cost. So total profit is going to be the quantity produced times the amount over the average total cost that is the price. So this from here to here and over from quantity F2 down to quantity 0, that shaded triangle right there is this firm's profit. Make sure you mark it right at the point where the quantity vertical line crosses the average total cost curve right here. In order for them to make a profit, marginal cost, which is also, of course, price, needs to be above average total cost, okay? So that's what that should look like. Now, relative to your answer in part B, state what will happen to the market equilibrium and price and quantity of corn in the long run. Okay, well, we've learned that since this is a market, and now that there's profit in the market, okay? Now that there's profit in the market, more farmers will decide to grow corn, which means the supply in the market is going to increase, bringing the price eventually back down as more farmers grow corn. So the overall market supply of corn increases, the price is driven down, but the overall quantity is driven up in the market until each firm is once again at long run equilibrium, making zero economic profit, okay? So that's going to be long run. That's going to be the long run equilibrium right there. So that's what's going to happen. So in the long run, more farmers will grow corn, which will shift the market supply curve to the right. This will drive the price of corn down and increase the quantity of corn in the overall market. Individual corn farmers will be producing less now, so they'll actually drop from here back to here. The individual farmers, as more farmers grow corn, and the price drops, the individual farmers will grow less, even though in the market the quantity is going to go up. In the overall market, there'll be a lot more farmers in the market, so the individual farmers may produce a little bit less, right? So don't get that confused, okay? But in the long run, the individual farmers or the individual firms will once again be making zero economic profit, where price equals average total cost, okay? Now, part D, soybeans are produced in a perfectly competitive market. Assume farmers can grow either corn or soybeans on the same land. What happens to the price of soybeans in the next planting season if the price of corn increases? Okay, well, if the price of corn goes up, that means that farmers are going to want to grow more corn, right? If the price is going up. So if farmers grow more corn, they're changing from corn from soybeans. So farmers will grow less soybean and more corn. So the supply of soybean in the market will shift to the left, which means that the price of soybeans will go up and the quantity of soybeans will go down. So since more farmers will grow corn and not soybeans, the supply of soybeans will decrease, driving the price up the price, okay? Part E, assume instead that the government sets a binding price ceiling in the corn market. Draw a new, correctly labeled graph for the corn market and show the binding price ceiling as P sub C and the quantity purchased by consumers in the corn market QP. Now, what's confusing about this is if you remember, when you have a price ceiling that's effective, that's below the market equilibrium price. So there's going to be an oversupply, okay? Because I just said that backwards. There's going to be an over demand because the price is lower, right? So I talk in opposites. What's going to happen is there's going to be a price ceiling set down here. I should probably say that, right? Let me just do something really quickly here. And let's just change that real quick. This is a price ceiling, right? If I could spell it. Okay, whoops. Okay, so here it is, okay? And in order for it to be effective or binding, it's going to be below the market equilibrium. I'm just getting this guy, right? So you want to make sure you have it below. And then the amount that's going to be purchased is simply the amount that's going to be supplied. Even though the demand at this lower price is way out here, here's where the demand is, but the only thing that can actually be purchased in the market is what's grown, is what's supplied. So this is where you would mark that right there, okay? So that's what that last graph would look like. That's your price ceiling, okay? Binding, right? And that's key, binding, because if the price ceiling, if it was up here, it would not be a binding because the price, all that's saying is the price can't go above that line. Well, the price doesn't want to go above the line because the market price is here. So in order for a price ceiling to be binding, remember, it's got to be below the market equilibrium. So now the price can't go, now the price can't go above the ceiling, even though it wants to go up here, it can't, okay? So that's problem one. Any questions, Eric, on problem one? Are you good? Are you good? Okay. Problem two. Okay, this is a little bit different because instead of talking about marginal utility, we're talking about marginal benefit in dollars, okay? Now, the problem only gives you total benefit of good X and good Y at each of these quantities. And you can see the same principle is happening here. As we buy more of good X and more of good Y, our marginal benefit for each additional unit is lower because we're getting more. I mean, we really want a good X, we really want a good Y, so we get a lot out of the first one, less out of the second one, less out of the third one, and once we have 4, that fifth unit of good X and good Y, whatever it is, if it's cupcakes or cookies or whatever they are, doesn't give us a lot of a benefit, okay? So we've got diminishing marginal benefit. Just like we had diminishing marginal utility. So it's the same principle, but we're not using utils here, we're using dollars for marginal benefit, okay? Now, just as a reminder, the demand curve on just a general supply and demand graph, the demand curve is the marginal benefit curve, and the supply curve is the marginal cost, okay? Just to remind you of that. So the problem states, if I could pull it up here, the problem states that we have Martha, who has a fixed budget of $20 that she's going to spend all of it on good X and good Y. The price of good X is $4 per unit, and the price of good Y is $2 per unit. And this table right here shows the total benefit measured in dollars that Martha receives from consuming each of these goods. So the first thing that they're asking here is, what is Martha's marginal benefit of the fifth unit of good X? Well, because I added, and I encourage you guys to do this on your test. If you get this, go ahead and calculate all the marginal benefits right away, all the changes, right? So this question is very, very easy, right? The marginal benefit for the fifth unit of good X is 1, right? Because you're going from 40, a total benefit from 40 to a 41, so that's a marginal benefit of 1, okay? So that's that easy answer. B, calculate the total consumer surplus if Martha consumes 5 units of good X, show your work. So consumer, now this is probably a little bit confusing to you guys since this isn't on your typical demand and supply graph. So the way you want to do this is you want to look at what does 5 units of good X cost, right? And since the price of good X is $4, then 5 units are going to cost Martha $20. Okay, so that's the cost. Her total benefit we see right here, total benefit to consume 5 units is 41. So her total consumer surplus is her total benefit minus cost, which is 41 minus 20 equals a total consumer surplus of 21. Okay, not so hard. So her total consumer surplus to consume 5 units of good X is $21. Okay. And you want to explain that, right? As I did right here. Okay. What is the optimal for Martha, knowing what the prices are and knowing what the marginal benefits are? What are the optimal? What's her optimal combination to get her optimal benefit? Or when we use utils, we say optimal satisfaction, right? Well, if you remember, this is review. In order to get optimal benefit, we want the marginal benefit per dollar to be the same for both goods. So we want marginal benefit, and I should have put, actually I should have put here, let me just change that. I should put right here X, right? That's X. Oops. And this is Y, right? And this is Y. Okay, so to make it a little bit easier, right? So we want this to be equal. Now, when we look at, well, let's see what they're asking here. Okay, they're saying that Martha is currently consuming 4 units of, so I skipped C, sorry, 4 units of good X and 2 units of good Y. Is this optimal? Well, no. Why? Because 4 units of good, let me just jump back here. Let me go back here and see. 4 units of a good X gives you a marginal benefit of 4, right? 4. That's not 40, remember marginal, so it's 4. So the price of a good X is 4. The marginal benefit is 4, okay? She's consuming 2 units of good Y, okay? So 2 units of good Y gives her a marginal benefit right here of 8, right? 10 to 18 is 8. That's 2 of good Y. And the price is 2. So that's going to be a marginal benefit of 8 over 2. That ratio is not equal, right? 4 is greater than 1, okay? So that's not equal. So the marginal benefit per dollar for good X is 1. The marginal benefit per dollar of good Y is 4. Therefore, 4 is not equal to 1. So that's why that's not optimal. So now they're asking what is optimal. Okay, what is optimal? That's part of D, right? What is optimal? Well, what we want to look at here is where the ratio is going to be equal, right? So we know that the prices are 4 and 2. So we need to find where the marginal benefit of X is twice as big as the marginal benefit of Y in order for this ratio to be equal. And we find that to be true at the third unit of good Y has good X has a marginal benefit of 8, and the fourth unit of good Y has a marginal benefit of 4. So 8 is twice the size of, as big as 4, just like the price is twice as big for it's twice the price of good Y. So that works. The only thing we want to make sure of is that going to spend her total income of $20? And we can see here that the price of 3 good X's will cost 12 because they're $4 each. The price of 4 good Y's will cost $8 because they're $2 each. So that's going to be 20, right? So that's going to spend her total income of $20, and is going to give her the ratio where the marginal benefit per dollar is equal. Okay, so that's going to be 3 units of good X and 4 units of good Y. Okay. All right. Part E. Okay, now we're going to look at 3 scenarios and decide whether the optimal, in order to remain optimal, should Martha buy more of good Y, less of good Y, or the same amount of good Y. So the first scenario is the price of good Y doubles. So what's going to happen? Okay. Oops, wrong one. So if the price of good Y doubles to 4, then the marginal benefit for good Y will need to double to 8 because you still need the same ratio, okay? So if the price now for good Y is 4, we need to find somewhere that the marginal benefit for good Y is 8, which is going to be way back here at 2, okay? So we've gone from 4 to 2, all right? So that tells us that she's going to want to buy less of good Y, because in order to get this right here, she only needs to buy 2 units of good Y, which in 2 is less than 4. So for this first scenario, she's going to buy less of good Y, okay? And that just makes that just makes intuitive sense. If the price of something doubles, you're just going to buy less of it because, you know, it's going to give you, you're going to be less, it's going to be a benefit of it's going to go down as the price goes up. That's just common sense, actually. Okay, so the next one here, Martha's income gets cut in half to 10 with the original of prices. What's going to happen? Okay, so if her income gets cut in half, then Martha still needs, I should say, needs to make sure the marginal benefit per dollar for good X and good Y are equal. Martha's optimal combination now is 1 unit of good X, cost of 4, and 2 units of good Y, cost of 4. Because she only has $10, but she's only going to be able to spend 8. But the bottom line here is that in order for her to get that same ratio, which she's dropping back to she's only able to buy 1 unit of good Y, right? So that has a marginal benefit, if we go back up and look, of 16, okay? So 16 over 4, which is the price, is a 4-to-1 ratio. So she needs a 4-to-1 ratio over here because the prices 4 and 2 have not changed, remember. So in order for her to get this marginal benefit right here of 8, she needs to be at the, she needs to consume 2, okay? And that's going to cost her less than her $10. Anything else is going to mean she spends over her $10 income. But the bottom line here is that she's going to consume less of good Y because 2 is less than 4. Because, see, she was consuming 4 here, right? 4. So she's going from 4 to 2 of good Y if her income gets cut in half. Okay. Lastly, Martha's income doubles and the price of both goods double. What's going to happen? Well, if Martha's income doubles and the price of both goods double, then the same marginal benefits for both goods make the ratios equal, right? So because we're going from 4 to 8 and from 2 to 4, and then if we use the same you know, if we say the third unit of good X and the 4th unit of good Y, which is a marginal benefit of 8 and 4, which we can prove up here again, 8 and 4 right there, right? That's going to add up to her new income of 40, right? So her income doubles, but her quantity of good Y and, by the way, good X will stay the same. Okay, that finishes problem 2. Eric, do you have any questions? No? Are you good? Okay. So that's problem 2. One more to go, guys. And it won't be that long, I don't think. This one is, we have a graph where we have a simple supply and demand, and the government is going to get involved in the market. This is a market for widgets. All right, widgets. So calculate the total producer surplus at the market equilibrium price and quantity. Show your work. So what you want to do is you want to look at the producer surplus, okay, which is going to be right here, okay, because this is the market equilibrium, and the producer surplus is everything below the price and above the supply or the marginal cost curve. That's going to be your total producer surplus, which is just calculating the area of the triangle, which I'm calling this the base right here, okay? So it's 1/2 the base, which is 1/2 of 20, or you can call the base here, either way, okay? It's a 1/2 of 20 times the height. So if you call this height, then it's 1/2 the base, which is 1/2 of 20 in quantity, right? Because the quantity is 20 and the price is 20, which makes this real easy. So we have a producer surplus of 200, okay? Next question, what happens if the government imposes a price floor at $16? Is there a shortage, a surplus, or neither? Well, the answer is neither, because a price floor means that the price cannot go below $16, okay? I mean, yeah, right. The price cannot go below, and it doesn't want to go below, right? Because it's already up here, okay? So a price floor below the market price doesn't do anything. So the answer is neither. A price floor set at 16 would be ineffective because the market equilibrium price is already above the floor, okay? So now they're asking us, what if instead the government imposes a price ceiling at $12? Is there shortage, surplus, or neither? Okay, well, a price ceiling is a whole different story. If we put a price ceiling down here at 12, right, it means that the price can't go above. So it's going to block the price from going up to where it wants to go, which is 20. It's going to stop it right here at 12, which means we're going to have a supply of 12 and a demand of 24. So if the demand is more than the supply, we have a shortage, okay? And you can just say a shortage. I actually went through and explained exactly what it was because the numbers are here. You can see that we have a shortage. Whoops, sorry about that. We have a shortage of 12 because demand here at a price of 12 is 24 and supplies is 12. So that means 12. Okay, next question. Let's say that the government restricts the market output to 10 units. Calculate the dead weight loss. Okay, well, what we want to do there is we want to get this guy out of the way so it doesn't confuse us. And at a output of 10 right here, the dead weight loss is going to be that output marked by the output of 10. I'm trying to get him out. Well, sorry. Over to the allocatively efficient point where marginal cost, which is supply, equals demand right here. So over to that point. And this is the socially optimum or the allocatively efficient or the market equilibrium. And you draw that triangle and you calculate that, right? So we calculate that by saying 1/2 30, because 30 is, how did I do that? I went from 40. Actually, that's not even right. How's that? Wait a minute. What did I do? Let's see. 10 to 20 is 10, right? Okay, let's see, 130. Oh yeah, right. I'm just seeing this wrong. Sorry, my eyes are bugging. 10, right? 10 here to 40 here. Sorry about that. I thought that purple line was causing me to see cross-eyed. Be careful with these because you can easily see it wrong. So you've got 40 at this point and 10 at that point, which means the base is 30. And the height is 10 to 20, which is 10, right? So it's 1/2 a base times the height. So our deadweight loss is going to be 150, okay? Easy enough. Just don't let all your lines and the triangles confuse you, okay? Like it just did me. Okay, there we go. All right, now, lastly, we're saying that the price decreases from 20 to 12. Calculate the price elasticity of demand, show your work. And then is it going to be perfectly elastic, relatively elastic, unit elastic, or what is it, all these choices here. So we're going to figure that out. Okay. So let's figure that out. Let's jump back over here. Now, if we're going back to how we calculate price elasticity of demand, it's going to be the percentage change of quantity over the percentage change in price. So we know that price went from 20 to 12, right? Let me make sure, yeah. 20 to 12, okay? So price went from 20 to 12. It means that the percentage change in price using the midpoint formula, let me get my blue guy here so let me get this guy. Using the midpoint formula, and this is all review, it's going to be where we ended up minus where we started, right? Because it's going from 20 to 12. So we're ending at 12. So the price is dropping, right? So we're going from where we ended up minus where we started divided by the average of these two. That's the midpoint formula. And then when we look at 20 to 12 or 12 to 20 on the graph up here, let me just copy this guy so I don't got to keep bouncing him around. So we're going from price. Now we're just using the market as it is, right? So we're going from a price of 20 right here to a price of 12 right here, which means we're going from a quantity of 20 down. Actually, I went the wrong way. Sorry. Woo. Demand, Mr. Charlton, demand. Okay, so we're going from a price of 20 to a price of 12, which brings us up to a quantity of 24. So we're starting at 20, a quantity of 20 here at price 20, and going to a quantity 24 at price 12. So we're ending at 24 and starting at 20. So that's how that's going to work, okay? So that's why we're ending at 24 quantity, starting at 20. So that's, the end point, the beginning point, divided by the average, and then figure out your math, and you get and remember, we always use the absolute values, so we get an absolute value less than 1, okay? Now, the way they did it with the AP board is they used the regular standard percent change formula that you learned in math, where you simply take where you ended up minus where you started divided by where you started, not the average, where you started. That's what they used. I don't know why, but that's what they used. So I just showed you that would give you a little bit, your answer is a little bit different, but it's still, the absolute value is still below 1. So your overall answer is going to be the same. It's going to be inelastic because it's less than 1. So no matter which formula you use, your answer is going to be at that point, at that price range on the demand curve is relatively inelastic, because either formula gives you an absolute value. So don't worry about the negative. This is absolute values of less than 1. Okay, and there you go. That's it. And if you guys are watching the video, you're going to have plenty of time before the quiz because we're going to have a break. So while I'm on the video, let me just bring up our calendar, okay, really quickly to show you. Let's see, where is it? Calendar. I might not have changed the discussion, but it's due. It's due. I didn't, let's see. The discussion 7 is due right here, but your assignment 9 and your quiz 9, and of course we haven't even got to a discussion 9 yet. We're kind of behind in that, but we'll get caught up. But just know that right now we're on the 12th, and because of winter break, your quiz isn't going to be due until March 3rd. So I'm probably going to have our quiz video session during this week right here, maybe here, but probably here, okay? But I will certainly let you guys know. Since this is Tuesday, Wednesday, I'll probably have it this last week of February, okay? And so I will go over the free response to quiz 7 because some of you missed some things on there that I want to make sure. I want to make sure you understand that. Well, let me just show you really quickly on the video since I've got it right here. Where is it? I think it's right here. Well, I thought it was. Yeah. This is the confusing part right here. I didn't have 0 right here, okay? So really quickly, marginal revenue is 0 right here, okay? So wherever marginal revenue is 0, that's where total revenue is maximum. So that's your point right there. But that's the point, the price and the quantity right there that that gives you total or maximum total revenue, wherever marginal revenue is 0, which is obviously right there, if that's there, okay? That was what was confusing a lot of you. The other thing is that profit, if you're operating as a monopoly, profit is going to be where the price is, which you can find where marginal revenue equals marginal cost right here and move up to the demand curve right here. Well, whatever amount the price is over average total cost, which is the purple line, that's your profit, right? Times quantity. So 4 to 5, that's a $1 profit times 200, okay? Now, when we perfectly price discriminate, we're going to, this is confusing, I think, but the revenue, it asks you guys for total revenue, which means that when you perfectly price discriminate, you charge every consumer the price they're willing to pay. Whoops, trying to get this guy out of here, which I probably can't. Let me move him out. This is tricky. Okay. Which means you charge everyone the maximum they're going to pay from $7 all the way down to where demand equals marginal cost right here. So if you were able to perfectly price discriminate, the purple would be your total revenue. So you figure out the area of this triangle and add it to the area of this rectangle right here, okay? Now, the only other thing is, in order to make zero economic profit, price needs to equal average total cost right here. So 0 economic profit would be at 300 and a price of 4, and the socially optimum or the allocatively efficient is going to be where price equals marginal cost right here. Okay, where price equals, so $3 for price and 400 in the quantity. Okay. And this is the producer surplus, right? I'm sorry. This is the consumer surplus right here. If the monopoly were forced to not price discriminate, right? If everyone paid $3 and they produced 400, if you had the price set where it's socially optimum, this blue would be the consumer surplus. Okay, so but that's assuming that everyone's paying the same price of $3, right? If you price discriminate, then everyone pays the maximum that they would pay. So this guy right here is going to pay $6.99 all the way down to $3. Okay, and I'm running out of time, Eric, and everyone else, because I've got a macro at 8. So I'm going to end it there. I hope that cleared up any questions you guys had about the free response on the quiz. Okay. I'm going to stop the video.